All right, hello, Dr. Matthew J. Traum here. This is a STEM Tank video that describes how to use the instrument which is in this box, which is a radius gauge finder. This box came in your kit. It looks like maybe old time chewing gum, but when you open it up, you see that there is a metal instrument inside that looks kind of like a pocket knife. So I'll move the packaging out of the way. When I open it up, though, instead of blades or things that you would find in a pocket knife, it's actually just this series of flat pieces of steel that when I put them together, you can see they've got kind of these radius cutouts in them that are ever increasing in diameter, right, as you go down. And then on the other side, it's actually the exact opposite shape, right? So instead of being concave, it's convex, and they're ever increasing diameters as well. So on the gauge itself, I've got stamped R1 to 6.5. That means that I can measure radii between 1 millimeter and 6.5 millimeters with this radius gauge. And of course, because I've got both the external and the internal, I can measure internal radii and external radii with this instrument. So let's actually test it out. And initially, just to give us some confidence that we know what we're doing and we're measuring a correct value, I'm going to do something it's a little kind of which is I'm going to take this pen and I'm going to measure the radius of the pen first with a micrometer, so that when we compare the value, or when we measure the value with the radius gauge, we basically know what we're going to get in advance. So this is not the thing that you would normally do. You normally, if you've got something that's perfectly round, you just use the micrometer to measure its diameter and you'd be done. Radius gauges are meant to measure curvature of things that you can't get a micrometer around because either they're not complete, or they're too big, too small, something like that. So I'm going to start out by making sure that this micrometer is set in millimeters, which it is. It's in absolute and not incremental measurement. Okay, and I'm going to zero it. And every time I take a measurement with a micrometer, I'm going to recalibrate it and I'm going to set it to 0. See, this one was slightly out of calibration. So I'm going to zero it. There we go. Okay, and now I'm going to take my pen. This is just a standard Bic pen that I had sitting on my desk, and I'm going to measure the diameter of my pen. So it's a little bit bigger than 5 millimeters, a little bit bigger than 6, in fact. Ooh. Oh, there we go. Okay, so now I've got the pen in there, and let's get his exact value. Okay, so it looks like 8.13 millimeters. 8.13 millimeters. Okay, so I'm going to put the brake on to remember 8.13 millimeters. I'm going to set this aside. And I'm now going to bring up my radius gauge. Now, 8.13 millimeters, that was a diameter, right? Because I'm measuring across the entire pen. And for the radius gauge, I want to split that in half because a diameter is twice a radius, right? So 8.13 divided by 2 is something like 4.05 millimeters, right? Something like that. Let me show you what happens if you very blatantly choose the wrong value. So I'm going to pick a radius of 2, knowing that the value is actually closer to 4. I'm going to pick 2 here. Which is wrong, right? But just to show you what happens. So I'm going to stick the pen onto the radius gauge, or stick the radius gauge onto the pen, and it's perhaps a little bit hard to see, but right here where the radius gauge is interfacing the pen, there's a pretty significant gap, right? You can see that the radius gauge is not pushing up solidly against the pen. There's an air gap in there. So what that tells me is that the radius gauge is too small. Let me also, just so that you can see what happens, let me pick one that's too big. So I'm going to pick one here that is, okay, 6.5, right? We're again shooting for half of 8. So something like 4, and this one is 6.5, so it's definitely too big. And when I put this too big radius gauge up against the pen, you can see it doesn't line up, and the pen can kind of wiggle back and forth, and it doesn't sit in there snugly because that radius is too big. So that's how you know you picked a radius. It's either too small or too big. If it's too small, there's an air gap between the object that you're trying to measure and the radius gauge. And if it's too big here, you can't seat the object onto the radius. It can slide back and forth. Okay, so let's now pick the correct one, which is 4, right? And you wouldn't know this in advance, right? Because you wouldn't have had that micrometer measurement in advance, but this is just for purposes of getting us acclimated. I do want to check to be sure. I made an entire video and then I realized right at the end that I messed up because I had 2 of these gauges that were sitting right next to each other. So you do want to make sure that you just have that a single gauge and not 2 of them lined up by accident right next to each other. There's 4. I'm going to take the pen. I'm going to put the radius gauge right on the pen, and the alignment is excellent, right? There's no air gap between the radius gauge and the pen. The radius gauge can, the pen can kind of move the radius gauge back and forth without slipping. So I would conclude, not knowing this value to begin with, that the radius of this pen is 4 millimeters, the diameter is 8 millimeters, and that's awfully close to the value that I measure, the exact value that I measure with the micrometer. Okay, so that's how this guy works. Now, let's do it kind of in the opposite order now, to make sure that we know what we're doing. So I'm gonna grab just a different pen, and I know that this blue pen is quite a bit bigger than the gray pen, right? So I'm expecting a bigger value. So what I'm going to do now is I'm just going to guess, right? I know that it can't be 4 because that smaller pen is 4. So let's do 4.5. Let's try 4.5. Okay, so here's my 4.5 radius gauge. I'm going to sit the pen up and put the radius gauge on, and you can see there's an air gap there, right, between the 4.5 radius gauge and the pen. There's a little gap, so 4.5 is too small. So let's try 5 and see what happens. So here's 5 all by itself, and well, that's pretty close. Might be a little bit too small. It's probably hard to see in the camera, but there is just a slight gap there at 5. So let's try 5.5, and this is precisely, by the way, what you would do. Is you would just run through the different gauges until you find the one that lines up. Now, I've got a situation here, which is exactly what I described before, is what you want to avoid. It is perhaps hard to see because these are so thin, but I do have 2 of these guys that are just stacked one on top of the other, and they're sort of attached to one another. So I need to be a little bit careful. Let me just get them separated here off camera. Boy, they're really stuck together. Okay, so let me just get them separated. Sorry, guys, this is technical difficulties. There we go. Okay, so I got them separated. All right, this one is 6. This one is 5.5. I was measuring 5 before, so let's just go up to 5.5 and see what happens. Okay, so that is a really nice fit right there, 5.5, and 5 was just perhaps a little bit too small. So I would say that the radius of this pen is somewhere between 5 and 5.5, which means the diameter is going to be somewhere between 10 and 11 millimeters. So I'm going to bring my micrometer back and just confirm that that's the case. Again, I've got to 0 it, so I'm going to pull the brake off. I'm going to run this guy back down to 0, right? Even though this is tedious, we always calibrate before we take a measurement because you never know if the micrometer might be out of calibration. Okay, so it's 0'd correctly. I'm going to open it up, and again, remember, I was expecting a value somewhere between 10 and 11 millimeters for this pen based on a radius measurement, somewhere between 5 and 5.5 millimeters. So let's just open it up there a little bit above 10.5 and we'll see what happens. Ooh, okay. So that's not bad. That fits pretty snugly just the way it is. Let's open it up maybe a little bit more. Okay, and bring this down. Okay, so the value that I'm getting using the micrometer is, all right, so about just a little bit over 11, right? 11 millimeters. That turns out that snug fit that I got with a 5.5 millimeter radius gauge, that one is probably the one that ultimately fit the best, given now kind of confirming the measurement with the micrometer. So anyway, not too bad, right? I guess somewhere between 10 and 11 millimeters, and I ended up with 11 millimeters as the value that I got when I actually took the actual measurement. So that's not too bad. So we've looked at kind of things that we already know are circular because we can measure their diameters. Now, what about something where we can't measure its diameter because it's circular? So what I have here is the kind of profile of the case of my cell phone. And so this is a good example of something that's curved and might be difficult to measure the radius of or measure the diameter of because it's sort of flexible. So I'm going to take my radius gauge and I'm going to engage it and just see what happens. So that's actually pretty good. That's the 5.5 right there. So that actually looks pretty good all by itself. Let me just move up to 6 and see if that's any better. So here's 6. Okay. So 6 is actually, I think 6 is probably a better fit. Yeah, it doesn't wiggle too much. So I would using an external radius with this radius gauge, I would guess that this external radius is probably 6 millimeters, meaning its diameter is about 12 millimeters. So that's how we do an external. The other possibility is an internal radius. So I grabbed this kitchen timer just from the kitchen of my house, and it does have some external radii that are quite big, right? This one is way bigger than 6. You can't use the radius gauge to measure that one because it's too big. Some of these buttons, okay. So this button looks like it's about a 6, maybe a 6.5. This button is a bit smaller, so you can see there's an air gap there, and I want to go a little bit smaller with that guy. But this kitchen timer I picked because it also has internal radius features, which are these kind of bevels around the face of it. So just to give you a sense of how to measure those, I'm going to go with the internal gauges, which are the ones that have the external radius. And so not really knowing what this is, I'm just going to pick a value. So let's try 6. So same idea. I'm just going to bring this guy in, and I'm going to see if it matches up nicely with that curve. Yeah, and it seems to actually. So 6 is probably a good estimate, but let's see what happens if we pick something that's way too small, right? So let me pick 2 again. So here's 2, and I bring in 2, right? And 2 is very clearly too small, right? Like there's very clearly a gap between the radius of the kitchen timer and that 2 radius gauge. And then let's just see, since we're here, we thought that 6 was good. Maybe 6.5 is perhaps better. Yeah, no, there's actually a little bit of a gap there. A little bit of a gap right here on the edge between 6.5 and this internal radius. So my guess is that the internal radii of these features is 6 millimeters. And that really just gives you a sense of how to use the radius finder. Okay, so that's it. Just wanted to kind of walk through that example of how to use this guy. And we'll see you in class. Thanks. Bye.